In the late 1940s and early 1950s, the United States Air Force USAF and the National Advisory Committee for Aeronautics NACA, the precursor to NASA, realized there was a significant gap in their understanding of high-speed, high-altitude flight. The jet aircraft of that era had already achieved supersonic speeds, but they couldn't explore the realm where the atmosphere becomes extremely thin. This is where the need for a hypersonic aircraft emerged. The primary goal was to create a vehicle that could fly at speeds greater than Mach 4.5 and reach altitudes above 100,000 feet. This wasn't just about breaking records, it was about gathering vital data on aerodynamics, flight control, and the physiological effects on pilots in an environment similar to outer space. Thus began the competition to design this aircraft. North American aviation emerged as the winner with a truly radical concept. The X-15 was no ordinary plane. Its long, sleek shape with a thick tail fin was engineered for stability at hypersonic speeds. The most unique part of the X-15 was its propulsion system. Initially, the X-15 used the XLR-11 rocket engine, but it was later replaced by a much more powerful engine, the XLR-99 rocket engine. This engine used a fuel of anhydrous ammonia and liquid oxygen. With its immense thrust, the engine could propel the X-15 to speeds over Mach 6 and altitudes above 350,000 feet. This was the boundary between the atmosphere and outer space. However, there was one major problem. The X-15 couldn't take off on its own. Its heavy weight and fuel-guzzling rocket engine made a conventional takeoff impossible. The solution: the X-15 was carried by a B-52 Stratofortress bomber to an altitude of around 45,000 feet, where it was then released to begin its powered rocket flight. The X-15's flights were a thrilling spectacle. After being released from the B-52, the pilot would ignite the rocket engine and blast into the sky. In just a few minutes, the X-15 could reach unimaginable speeds and altitudes. During these flights, the pilots faced extraordinary challenges. At high speeds, friction with the atmosphere made the aircraft's surface incredibly hot, reaching temperatures over 1 to 100 degrees Celsius. To counter this, the X-15 was coated with a heat-resistant nickel-chromium alloy. At extreme altitudes, the atmosphere became so thin that aerodynamic control surfaces like wings and fins were ineffective. This is where the Reaction Control System (RCS) came into play. This system used small thrusts from rocket nozzles to control the aircraft's orientation, just like those used on a spacecraft. The pilots who flew the X-15 were a group of incredibly brave and skilled individuals. They were not just test pilots, they were also astronauts. In fact, 8 of the X-15 pilots were awarded astronaut wings for successfully flying above 50 miles, about 80 kilometers, the boundary recognized by the USAF for spaceflight. One of the most famous names is Neil Armstrong, who would later become the first human to walk on the moon. His experience flying the X-15 gave him a deep understanding of the space environment and the importance of reaction control systems, knowledge that proved invaluable for the Apollo missions. The X-15 program ran for nearly 10 years, from 1959 to 1968, and produced 199 flights. During this period, the program successfully collected invaluable data. The data gathered from the X-15 flights became the foundation for future spacecraft development. The X-15 didn't just break records. It also proved that a winged rocket plane could operate at the edge of the atmosphere and return safely. This concept became the basis for the space shuttle that NASA would use years later. The X-15 program also taught us about the limits of material endurance, flight control systems, and human physiology. It was a masterpiece of engineering that was far ahead of its time and played a crucial role in the transition from atmospheric flight to space exploration. The X-15's flights were a thrilling spectacle. After being released from the B-52 at an altitude of about 45,000 feet, the pilot would ignite the XLR-99 rocket engine. This engine, capable of generating up to 57,000 pounds of thrust, would propel the X-15 skyward at an incredible rate. In less than 2 minutes, the aircraft could reach its top speed and maximum altitude. So, the X-15 was more than just the fastest or highest flying aircraft. It was a bridge, a pioneer that stretched from the supersonic jet era to the age of space exploration, paving the way for humanity's dream of exploring the cosmos. Thanks for watching, and I'll see you in the next video.